So, good evening, at least it's evening over here, ladies and gentlemen, in the Friday stream, where today it's a special stream for me, because today I will not be the only one that's doing all the talking, because today I have a guest with me, and the guest is the one and only DigitalEntity, aka is the DigitalEntity, Konstantin, the original developer, the guy who created INAV, and the guy that knows really a lot about the control theory, speed loops, embedded microcontrollers, and all the magical stuff. So please welcome Konstantin.
Hi, everybody.
Yes, Konstantin, now you can talk. So, okay, if everything is fine with the audio and you can hear the Konstantin as well, let me make a short introduction why this live stream is today created. Something like last week, I decided to port the GHST protocol that the immersion RC Ghost is using into INAV, and Konstantin took a look at the code and said, yeah, maybe we should improve it, because this does not really seem like a great idea in some of the edge cases. And one after the other, we came to a conclusion that it might be actually a pretty good idea to have something like the short talk about the RX protocols and the latest developments in the world of the serial rings, because 2020 is pretty interesting in that matter, because we have all those ghosts, tracers, and FRM 302 and other LoRa or not LoRa, depending how you're gonna call them, things. So the main topic of today's talk, bear in mind we might go pretty technical in the process, but if we will go too technical, then someone in the chat start waving the hands that we are probably going too far. So main topic will be RC protocols and radio system. However, let's begin with the pretty standard questions. Yeah, why INAV? What really got you into creating an own flight controller?
Well, it began in back 5 years ago, more than 5 years ago, where I wanted to build a quad. And because I was a poor guy that time, I had to stick with simplest solutions possible, which was CC3D. Some of you may remember that board, like the small processor, not much power, nothing on board, no barometer, no nothing. So the question was, how do I make it return to me? Because I don't know how to fly. I didn't know how to fly at that time. So the main question was, how do I get the quad back if I lose control? APM didn't work on CC3D.
No, of course not.
OpenPilot was not working.
No, it was working, but without GPS.
Yeah, true. It was working, but the thing didn't have enough memory to support GPS on OpenPilot. So what left? CleanFlight. Yeah, CleanFlight. It did the job. It was flying. It even returned to home sometimes.
Usually not.
But let's be honest. No, it was good enough, I'd say, for a beginner
Then
quad.
you have completely different memories from CleanFlight's capabilities and the GPS.
That may be true. Maybe I got lucky that time, but I got a few flyaways as well. So let's be honest. CleanFlight with GPS flew like crap. Well, crap probably flies better. So because it was an open source project, I started hacking it. Because that's what we do. If we want to improve stuff, we open the code and start thinking how we can make it better.
And 5 years ago...
At some point, I realized, 5 years ago, I realized that I pretty much wrote a navigation stack for CleanFlight. I might as well fork it off into something else.
And we have INAV right now, and the question is who remembers about the clean flight event? Probably even Dominic does not remember about the clean flight too much. So, okay, we have INAV. What next? We are doing this for 5 years. I say we because you are doing this for 5 years. I may be doing this for almost 4 years by complete coincidence. And after those few years, we have something that's pretty at least usable. Well, of course, we are not as far into the road as APM, but still we have something that works. So what next? And how do you imagine the INAV will evolve if it will evolve?
Well, obviously it will evolve. It now pretty much it has a solid community of developers now, a solid community of users. At the moment, I have very little influence on of the direction of the project. That's how crowdsourcing works.
Well, you're still the maintainer. You can always override what's happening on the Git.
Well, I prefer not to do that. Of course, I can be a benevolent dictator, but let's be honest. This project exists now for the benefit of the community, not for the benefit of me. So, community has the final say, I'd say, somehow.
Somehow, yeah, definitely. So, how do you think? What's the biggest challenge of being the maintainer of the open source project? A kind of pretty big open source project.
Yeah, it's actually quite big. I tried figuring out how big is it, and I lost count of lines of code. It grew like exponentially, and the main challenge is trying to match incoming feature requests to available developers. Pretty much, like users want everything now, and preferably bug free.
Of course.
But there is only so many developers working on it, and they all do this in their free time. They may receive donations or referrals from Banggood or whatever, but let's be honest, that's not nearly enough to work on the project full time.
No, 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 no. You cannot live from the open source, at least in the small hobby like the RC, definitely.
Yeah, so the biggest challenge is figuring out which features to implement, basically.
So, okay, now probably the question that quite a lot of people are waiting for. What's up with H7s?
H7, yeah, hot topic.
Yeah, exactly. Honestly, I'm getting a question when the H7 will be implemented in INAVs at least once a week for the last at least few months.
Let's look back a little bit. We started with F1. It has very little memory. It didn't have built-in serial inversion. It was pretty slow. So migration to F3 brought us. It didn't brought us much of a performance improvement, but it brought us more memory and built-in serial inversion, serial port inversion. So no more hacking S-bus because it's weird inverted protocol. Then there was a migration to F4, which costed us serial inversion, but instead we got pretty mighty CPU with a lot of memory. F4s are going to be around for quite a
At
while, I'd
least few
say.
years. That's probably. And we are
Yeah.
not talking about the 411s because they are pretty like whimsy little devices, but 405s will probably stay for quite a while.
Yeah, 405s, 425, 427, they are going to be around for at least few years. Next, F7 family. That's essentially an F4 plus serial inversion built in.
And slightly different memory architecture and internal architecture. There are some different.
Well, that's from a user perspective, it doesn't bring much of a benefit.
Okay,
except
the
built-in
user
serial
not
inversion.
from the user not, but I remember last year I spent quite a lot of time by speeding up the F7s on the INAV.
Yeah. Now, where do we stand now? We have we are very far from reaching limitations of F7 in terms of performance, in terms of memory, we're not nearly using all of the features of F7. So what does H7 bring us? Nothing in that sense. It's just a faster F7, but we don't need that speed at the moment. So it's being worked on. I have an F7 in front of me. It boots, it blinks at me. It connects to the configurator. It talks
that's
to
half of the success.
It's talks. Oh yeah, it took me a month to get it just boot and not lock up. Well, my month, not full-time month, like in the evening, over an evening coffee and things like that. But we have more pressing topics to implement. So F7 or H7 is a lot of work to do because it's a new processor with new bugs, new architecture, new drivers required, without bringing us much of a benefit. It's being worked on, but it's kind of low priority at the moment.
And that answer should hopefully satisfy everyone. So something is happening, but it's really not a super important topic, if not counting those who got themselves H7s and they are waiting for INAV support. But you should have read the release notes, right?
H7 will probably come in 2.7. Well, 99% probability.
Yeah. So half a year. This is probably the most probable arrival of H7, because we try to release INAV more or less every half a year.
Well, we try faster, but it's a matter of getting enough features and enough bug fixes.
Yeah, definitely.
We can release once a month, but
that I bet
what would that release bring our users?
I bet the users will not be very inclined really to upgrade their flight stack every month, because, well, if you spend some time on the configuration of the pretty new usually functions that you really would like to fly this thing instead of upgrading next month.
Yeah, exactly.
Okay, so now we go to the real topic of this conversation, and the new what's happening right now in the RC, the remote control, radio control. In 2020, we saw the FlySky pop up with the FRM 302, which is the LoRa system. We saw Immersion RC pop up with the Ghost, which is a LoRa system. And then we also saw the Team Black Sheep popping up with the Tracer, which they say it's not LoRa system. And we do have to believe them that it is not LoRa system. However, it's using the same chipset as the previous two, so it's capable of LoRa. And while, for example, the Tracer and the TBS decided to reuse the existing architecture for the Crossfire and made Tracer compatible with the Crossfire on the level of the flight controller and the connectivity, the Immersion RC Ghost decided to implement their own Ghost protocol. And like I mentioned in the beginning, during me porting the Ghost driver into the INAV, Konstantin decided that, well, maybe we should really think about what's happening inside of the protocol, because maybe it's not really the 100% safe. So before we go into the safe part of those protocol, why LoRa? Why right now in the 2020 we have those migration back to the 2.4 gigahertz instead of sticking with the good old 900 megahertz? And MFU, thank you very much for your kind donation.
So, LoRa.
The magical modulation.
Well, it's not magical. CDMA and spread spectrum has been around for quite a while. I'd say it's ancient technology. LoRa Semtex, actually, or how is that company called?
Yes.
Semtech.
Yes.
They just made it affordable. They made spread spectrum affordable to developers who now don't have to pay thousands of bucks for a transmitter.
No, because those radio
what's spread
chipsets
spectrum?
are cheap. So to put everything in context, the cost of the single transmitter that's capable of LoRa is right now a few bucks only.
Yeah. Yeah, previously it was spread spectrum was complicated system that costs 3-4 digit numbers in US dollars. So what's cool about LoRa? It's spread spectrum, and spread spectrum is a technology which can theoretically, and let's be honest, practically as well, recover signal that is has lower level than noise. Like imagine noise is louder, but you still can hear your transmitter talking. That's pretty cool. It comes at a cost. Bandwidth requirements in terms of radio spectrum of LoRa is much higher.
Mm-hmm.
And 900 megahertz, while offering long range and superior penetration,
Well, superior to
is a very
2.4 gigahertz because we can always go lower frequency.
oh yeah, we can go 177 megahertz and stick 1 meter antenna on top of our plane. Yeah, 900 is kind of sweet spot in terms of penetration and antenna size, but it comes with a very narrow band. It's barely sufficient for 1, 2, 3 pilots at a time before radio systems start to interfere with each other.
To put it into a context, the legal band is only a few megahertz, both in the Europe and in the United States. The 868 and 950 megahertz is really basically this. So this is only 1 or 2 megahertz up and down, and that's all.
I think in Europe it's 7 megahertz, but still. It's 7 megahertz. LoRa modulation usually uses channels of 500 kilohertz, which leaves only 14 channels to pick. And there are other users, and you have to hop between channels to avoid interference. So when you have more than 1, 2 people flying in the same spot, you might end up in trouble. And those people will be just creating issues for each other. 2.4, on the other hand, gives you 100 megahertz of spectrum to use. That's how many?
10, 12 times.
That's 15 times, 12
Yeah.
times, 12 times more. So instead of hypothetical 2 pilots, you can have 24 pilots at the same spot without messing
with
with
the
each
same
other.
chance of 2 receivers being at the same channel at one point and colliding during the transmission.
Yeah, 12 times more pilots at the same spot. Obviously, there are more users to 2.4, like Wi-Fi, Bluetooth, microwave ovens. They all use 2.4 gigahertz band, but 2.4 is usually quite narrow, quite short range. And this is where LoRa modulation comes in. Last year, I think, finally we got LoRa chips that work in 2.4 gigahertz band.
That's something 2019 that they really appeared in the shops. Previously, they were announced, I think, a year earlier, but it's 2019 when they really were available for the developers.
Yeah, I think they had evaluation kits available in 2018, late 2018, but they become mainstream in 2019, basically. So now we are combining benefits of 2.4 and benefits of LoRa.
So to sum up, we have the more channels, less collisions. The bandwidth available to the RC hobby is much wider because it's not 7, let's say, but around 100 megahertz. And we are also gaining a shorter antenna because this is always the argument that I come with that. Yeah, okay, 15 centimeter antenna for the 900 megahertz is super fine if you have something big, but with the upcoming regulations and limiting into the 250 grams, it's really like super hard to put a 15 centimeters antenna of the 3 or even 2 incher, while with 2.4 gigahertz at least it's doable, and we still keep pretty awesome, to be honest, features of the LoRa itself, which is a super high sensitivity of the receiver and being able to pick up signals that are below the noise floor. So yes, so this is basically why we are going in that direction. Or maybe this is only a hype and a willingness of the manufacturers to take our money. This probably depends on a person's personal view on the topic. Because I bet a lot of people will stay with the Crossfires because it works.
I'd say it also depends on your requirements. Like, I am not a racer, I don't race, but I hear from racers that when they have more than 4 people, 5 people flying in the same spot, they have brief loss of control sometimes with Crossfire.
Oh, this is the argument that we talked before, the pretty narrow band and a lot of conflicts happening. Still, let's say the 5-6 people when there are only 8 channels in the race band, this this is maybe not a practical experience, but if we go outside of the FPV community and go into the traditional flyers who just fly line of sight everywhere, it's not that uncommon to see 10, maybe even more. It's enough to take a look at the flight test videos from the Flight Fest from before years, when they really had like plenty of people still flying together, but I bet all of them were really using 2.4 gigahertz, not the 900 megahertz frequencies. So, okay, so when we, if we have more or less know why LoRa, now a brief detour to the tracer and why TBS is advertising tracer as not-LoRa. So, what does not-LoRa means in this case? How do you see it?
Not-LoRa, I'd say that's probably FLRC modulation.
Yes.
Fast long range coding something, I think.
Yes, something like that.
Which is a hybrid of traditional frequency shift keying and a forward error correction. Basically, you can tolerate more data loss.
More data loss, and from what the datasheets of the Semtech SX1280 shows, it has slightly more sensitivity on the receiver side than the FSK modem on this chipset. But this is not really like a huge difference, around 6 dBms, maybe even 9 dBms. So theoretically, you can go twice as far as with the traditional.
Well, it's not FSK. It's not exactly FSK. It's GMSK, which is still FSK under the hood, just the most efficient as it can get.
I think the official naming for the modem is FSK from the Semtech. They call it FSK last time I checked in the documentation. Oh, but on top of the slightly more sensitivity of the FLRC model, they also offer slightly more of the bandwidth. But still, to put it something in the context, while the FSK modem on the same chipset we are talking all the time offers the sensitivity of, I think, minus 96 dBms, the FLRC offers minus 106 dBms, which with 10 dBms of the difference, you can go. I had the numbers even written down somewhere, but in theory you should go at least a few times further away.
Yeah, I think it's a little bit more than 2 times more range.
It depends on how the FSK. I don't remember the exact numbers, by the way. While with the sensitivity, we're still talking about exactly the same chipset to which you connect exactly the same antenna when you switch this modem to the LoRa modulation, you can go as low as minus 134, I think, minus dBms. Still, this is not working definitely with those super high sensitivities, which is, by the way, way below the noise floor, because I checked somewhere and I think the average noise floor around the world is around minus 120 dBms. So this thing really has to work below the noise floor, what you mentioned before, Konstantin. And I think that the Immersion RC said that in the way they are using the LoRa modem, they start with minus 106 dBms, which gives us exactly the same sensitivity as the sensitivity of the tracer, if they are indeed using the FLRC modem. So if the same receiver sensitivity, which one still theoretically has the better range, and which one probably is still slightly faster and allows for the faster updates and the telemetry?
FLRC probably has better range. Oh, better range, more bandwidth.
And this is what
while offering similar range. Yeah, that's probably what Tracer is using.
During my walking test with the tracer and with the, how it's called, with the ghost in exactly the same conditions, the ghost actually won. And I think it's not really because the conditions and the distance was bigger, but because it was really able to figure out how to go below the noise floor and pretty much do a slightly better recovery.
Yeah, maybe. I didn't test them side by side. I don't have Ghost here.
Well, I'm a YouTuber. I'm getting paid for testing that kind of stuff. So, but when I got a Ghost and the Tracer, okay, this is like the investment. This is not for fun, of course. No, this is not for fun. This is my second job. But okay, so pretty much we explained what's the difference between the LoRa and not LoRa. And now let's go into this trend that we have recently about the super low latency RC protocols that connects the receivers to the flight controllers, and the chase of the faster update rate. Because to just to keep some of the numbers, when the FreeSky popped up with their D16 series, I think they offered something like 50 hertz update rate. I'm not 100% sure, but I think this is the case because of the length of the SBUS packet. Then we had some modifications, and at one point Crossfire and the TBS said, oh, we are doing 150. Then came the Ghost and they say that, oh, we are doing 222 hertz, and now Tracer is advertised as 250. Does it really make sense? Is there any price to pay for such a short delays and the high update rates?
If by price to pay you mean money, obviously.
Of course, but more or less from the technical point of view. What really are we losing when we try to basically to use kind of limited bandwidth? Because let's remember that even the speed of the serial port right now might be a problem to feed the data about 16 channels, which each channel is how many bits? I think 10, right? Yes, 10 bits.
It depends. It depends. You will pay with channel resolution, basically. You will have to reduce number of bits per channel so they can still fit in the bandwidth, which you cannot improve without losing range.
No, of course. But for example, SBUS itself is coding all the channels, which is 16 channels, each channel with the 10 or 11 bits resolution. I don't even... 11 bits resolution, still packs the CRC and at least 1 or 2 bytes of the extra flags. I think 1 byte. Okay, I don't remember, this is not relevant right now, and send this over the serial port. While what's Ghost doing with the GHST protocol, they are sending always 4 channels with the full resolution of the stick, basically channel 1 to 4 are sent as always, and then the rest of the channel they are sent one after another. So in one frame you can get channels from 1 to 4 and then from 5 to 8, and the next frame you will get 1 to 4 and from 9 to 12. What's really the problem with this kind of approach that kind of you were, I think, pretty right discovering last weekend?
Yeah, when I was reading up on the Ghost protocol implementation and details, it suddenly occurred to me that because of some weird glitch, we might always lose, for instance, channels 5 to 8.
And why this is
We
a
will
bad
always
thing?
get our sticks.
Why this is a bad thing?
Why? Imagine in this condition seeing that you are going to fly straight into the crowd of people. You flip the disarm switch and nothing happens. The quad just doesn't disarm.
Why?
Because the arming channel was channel 5, which flight controller is not receiving.
Because of some kind of weird glitch, and that second radio for a second or two just interfered with the timings of the frames that should be delivering channels 5 to 8, which has the disarm switch. Is this what you are basically saying?
Yes, exactly. Some interference, some receiver glitch may cause the receiver to not send us, or so the receiver may end up not sending channels 5 to 8 to the flight controller. And flight controller has no way of noticing this.
So that's kind of like a problem, because the argument that you had about the hitting the bunch of people and not being disarmed, this is really a pretty serious problem. So with that in mind, how do you imagine what would look like the perfect protocol that would connect the receiver with the flight controller? Maybe something like that exists already. How would you design the best possible, the safest and still pretty fast protocol for that?
I'd say Crossfire protocol is pretty close to what I would picture as a perfect protocol. In my opinion, a perfect radio protocol between the receiver and the flight controller. I am not talking about the over-the-air.
Of course, I will digress here for a second. People are not always realize that the protocol that connects the receiver to the flight controller is not exactly the same as the protocol that connects the transmitter with the receiver over the radio. With the wire, it's, for example, simpler because there's only one transmitter and one receiver. With the radio protocol, there might be multiple people listening, and you want your commands to hit only one receiver. So you have to have something like binding mechanism, you should have the CRC mechanism, and maybe even a few other special things that are not really required when you are working with the wire connection between board A and board B. So always the thing that you are getting out of the receiver is probably not even close to the thing that's traveling over the air from the transmitter to the receiver.
Yeah, exactly. And we are now talking about the protocol connecting the receiver to the flight controller.
Yes, exactly, because this is something that we had a pretty nice programming session last week.
Oh yeah, true. So in my view, the protocol should be atomic, deliver all channels or no channels. It has to be protected from data corruption, meaning CRC or some kind of checksum. It should be able to communicate link quality or RSSI without hacks like injecting RSSI into a channel.
Yeah, that's always irritating.
A good thing would be to have telemetry, preferably over the same UART and ultimately on the same wire.
Yeah, so there's less wires and no problems about having. Oh, for something for example, the smart port is doing. They are doing the telemetry in the pretty wrong way. When you have the S-bus connected as one wire with one speed, and then you have telemetry over a separate wire from a separate port connected to the receiver itself. So this is rather no-go.
Yeah, with F port they kind of fixed it, sort of.
But it's really like the F port internally looks like you put S-bus and the smart port doing the half duplex with the same port speed, but still it's really S-bus. This is not like unified both ends into one protocol. But
yeah, it's S-bus plus S-port. It's S-bus plus S-port, like blended together.
Not the cleanest solution probably ever. You mentioned that you think that the Crossfire protocol is pretty good in that regard. So what is missing? What do you think is missing for the CRSF? Because this is the exact name of the protocol we are talking about.
Actually, probably nothing.
So why it's not the perfect one?
It uses the extremely high baud rate. I would go much slower. Like the problem on a racing quad, not a big deal. When you have like only 2 or 3 centimeters between your receiver and flight controller, but on a 2-meter flying wing, when you have 1 meter wire between your receiver and flight controller, you don't want to go extreme speeds because then the wire length will become a problem.
Because yes, basically the wire will become an antenna and will be picking the radio noise. And by the way, I know that there are some people that to increase the range are installing the receiver on the tip of the wing, 1 meter. And the wire goes through the whole wing, close to the servo wires and different wires. And at the end, you really cannot be sure that the electrical signal from the receiver will come in a good shape to the flight controller itself.
We have CRC to detect such issues, but still, I would prefer not to have such issues in the first place.
Yeah, but even if you detect the issue and you will be able to reject the frame that is clearly broken, you cannot use it. It's a lost frame.
Yeah, if you get too many lost frames, guess what? Failsafe.
Yeah, and we do not like.
Speaking of failsafe, that's another feature. That's another feature I really want. The the RX protocol to have, like receiver itself, piece of hardware, is in the perfect position to detect link loss. It knows stuff. It knows exactly when a new packet should arrive over the air to the antenna. It knows to which antenna. It knows everything about what's happening around in terms of radio stuff. It's in the perfect position to detect that we lost our connection.
Yeah, because it has direct access to the radio chipset and can really communicate with full set of data with the radio chipset, not only with the stuff that receiver is sending to the flight controller.
Yeah, exactly. And I would expect the receiver to communicate this to the flight controller in terms of maybe 2 bits. 1 bit, I didn't get the expected frame, expected data over the air. You still get the channel data, but it's stale. It's from the previous packet. And if packet loss is too high, I want another bit, which is, okay, I don't hear the radio anymore.
So the data cannot be really trusted because the data is super old and it's basically a garbage.
Yeah. S-bus does that.
Exactly. That's what I wanted.
Crossfire doesn't
Why?
do that.
Why the best protocol in the world is not used? It's not really communicating a simple bit with the information I'm fail-safing. You don't.
Yeah, that's what I don't like about modern flight controllers. They communicate. They focus on communicating channels with lowest possible latency. They focus on telemetry, but they don't focus on really important stuff for long rangers.
Yeah, because this is something that also kind of important. The world does not end on the racing and being able to do the flippity floppy around the tree. Sometimes you just want to fly slightly further away in the distance, in which that probably recovering the quad might not be really that simple, because I don't know, there's a swamp or a forest, and the flight controller, which should bring the quad or the airplane home when you lost the signal, should be able to detect the information that this is just not working.
Yeah, exactly.
Oh, I'm sorry.
And
I'm sorry. We have a girl on the chat because Olya Lykova is joining us. Hello. Nice to hear. Nice to see you around. I'm watching your videos from time to time. Not that I understand, because my Russian is super rusty and I don't really get what's happening. But welcome. Okay, and now we can go back.
let's do a joint channel. I can do the translating.
No, the funny fact, I was learning Russian for like 4 years in primary school, but really I don't really remember much. No, it's like maybe a song or two like "Pust всегда будет солнце" and something like that. And alfabet mi уже знаем, уже pisze mi czytajem i все bukwy w wariatku bez ошибки nazywajem. But don't count more about the Russian language, I'm afraid.
That was actually pretty good.
Thank you. Unfortunately, I get completely lost after A, B, V, G, and then I don't remember anything. But okay, let's go back to the radio protocols and the fact that the clear information from the receiver to the flight controller that we are not getting the correct information is kind of crucial, and the trend to make the updates faster and faster, because the racers would like to have faster and faster updates, is not maybe something that all the hobby really desires. Yes, now you should nod and say that I am correct. Yes, I am correct. Yes,
yeah,
yes,
latency.
Yes, latency. By the way, do you think that you can feel the difference in the latency between 50 and 200 hertz?
I am not sure. When I was playing around with self-built long-range control,
just to make some extra bits of in the information. Konstantin, Alberto, and me, 2 years. That was 2 years ago. I think that was
2 years
that was
already.
2 years, at least 2 years ago. Each of us built his own version of the radio system based on the.
Oh, Pavel, that was more than 2.5 years ago.
No,
Actually,
that no.
I didn't yet move to Europe.
Oh yeah, that I would really have to check when was the last time I was working on mine. So, but to keep it in the context, three of us, three INAV developers, we built our own radio systems using the same radio chipset, LoRa Semtech SX1276, I think. At least that's what I was doing. You, Konstantin, went with the STM32. I used Arduino, and Alberto used the ESP32, by the way. So we basically know what we are talking about when we are talking about the over-the-air protocols, because we have some first-hand experience. Let's go back to the feeling of the latency now.
Yeah, so I was experimenting with latency, and I think my radio was talking something like 10 hertz. It was still S-bus at maybe 70 or 80 hertz on the wire, but over the air it was only 10 hertz. So I was only receiving signal from the stick positions every 100 milliseconds, and I was still able to do freestyle.
You really do not, apparently you really do not have to have 200 hertz update rates to do that. This kind of correlates with my experience in the field, because my radio system, I think, was working with, there was, I think, 60 milliseconds. How much is 60? 14 hertz? Something like that.
14 something, yeah.
My radio was updating with the 14 hertz. I was able to feel the difference that, okay, this is maybe feeling slightly more laggish than the 2.4 gigahertz free Skylink, which is working at 50 hertz. It was feeling different. However, like you said, I was able to fly around the tree, do the flippity floppy. Not racing, because I'm not a good racer, and that's completely different story. Still, I was able to fly. When I tested the Immersion RC Ghost in the long range mode, which also offers update rates of 12 hertz or something like that, one more time, I was really able to fly. It was feeling kinda strange, but it's not that it was making me fly much worse. And when I played with increasing the update rates and went from 50 hertz to 100 something, I was not really able to pick any difference.
Yeah, exactly. Our brain is incredibly flexible. It's able to compensate for pretty much anything.
So yeah,
And
marketing,
let's
right?
be honest. How long ago? Maybe 4 years ago, maybe 2 years ago, something like that. I was trying to figure out how fast a typical racing quad reacts. So what I did, the flight controller was commanding itself to do a flip.
Mm-hmm.
Zero latency.
Yes, because it's deciding I'm doing the flip now, so there is no radio involved.
Yeah. So it commanded from hover, let's go to 400 degrees per second roll. And it only started reacting, like barely noticeable increase in rotation rate took 30 to 40 milliseconds. And accelerating to full 400 degrees per second took more than 100 milliseconds.
By the way, I did very similar experiment this year with very similar results, by the way. Almost exactly the same numbers. A coincidence? I don't think so.
Yeah, because you cannot really beat physics.
No. Physics is a
no matter
physics
how
is a
hard
bitch.
you try. Yeah, nobody can break laws of physics.
So basically what you are saying that, yes, the latency is not good, but you cannot really... The fact that you lower the latency on one of the aspects of the control, because the control is the information that we give the command has to go to somewhere. The system that over there has to start doing something. For example, rotate in one of the axes. As then we still have the FPV feed that's feeding our brain with the information that something is really happening, and this is always delayed. Even if we cut the time between the stick movement and the reception of the command by the flight controller from, I don't know, 18 milliseconds to 4 milliseconds, it does not mean that we increased we lowered the total latency of the system 4 times, because there is still this physical aspect that we basically cannot really accelerate that much with the electronic tricks, because the motor just has to start delivering more thrust to start the rotation. And the fact that we have 4 hertz instead of 20 hertz does not mean that we are able to fly 5 times better.
Yeah, so if your quad is taking 50 milliseconds to react, increasing radio control latency from 10 milliseconds to 5 milliseconds will only give you not 2 times. It will give you how much?
I think
10%?
Maybe even less if you count really everything. So
yeah, less than 10% of improvement in overall latency. And we are not even counting latency in the video link. In the camera, in your goggles, your muscle latency
Yes, exactly,
between
muscle
your brain and your
latency,
fingers.
because your eyes has to pick up that something is happening, your brain has to process everything, and your brain has to send the signal to your fingers that to start doing something. And this is taking quite a long time.
Yeah, I would be curious to somehow measure the overall big control loop latency.
That would be a nice challenge.
I wouldn't be surprised if I will end up with numbers close to half a second.
I don't really want to guess, but please, let's remember what Konstantin said, that our brain is very good at predicting what's happening in the future, and it will compensate for the information that is does not have. This is not a PID controller that gets the information and does something. Our brain and we are thinking ahead of the happening. When you are flying,
Yeah,
when you are
exactly.
flying towards the gate, you probably can close your eyes and still will be able to predict when you will be really crossing the gate, because your brain looks into the future and is able to compensate for the delay that the physics and biology really introduces into the whole mix.
No, it can be even simpler. When you do a flip, you don't move your stick back to center when you are exactly back to level.
No, absolutely not. You learn when
You
to
start
release the
early.
stick.
You start earlier. You start earlier to release your stick earlier, much earlier, because your brain knows when your flip will end.
This is excellent example. Yes, you have to learn yourself of how fast you should release the stick when doing rolls to come back into the level, because your eyes does not have enough time to process everything and make the reaction back.
Yeah, so it's not about lowering the latency to the theoretically possible minimum. It's about keeping the latency constant between your setups, so you will be able to switch from one quad to the other and fly straight away without having to relearn how the quad behaves.
Mm-hmm. Exactly like that. Okay, our hour is almost ending, because we still have something like the 6 minutes. So maybe I will quickly go through the chat and let's find if there are some questions over there that people would like really to be answered. And Mike's Adventures, I think even for a few times, is asking, does INAV have the selection for the Red Pine protocol? You know anything about that, Konstantin?
What is a
I
red
have no
pine?
idea what's the Red Pine protocol. Maybe Google will tell us. Red Pine, isn't this somehow connected with those SPI receivers? Oh, my keyboard is not working? What the bloody... Oh, my keyboard died. That's complete. Okay, I'm Red Pine protocol. Oh, there is something about the Red Pine protocol.
Oh, the fastest radio protocol.
The faster.
That's already interesting.
So, no, Mike's Adventures, I don't think we have the support for that. However, if this is somehow connected with the SPI receivers, because I think this is somehow connected with the SPI receivers, I saw that there was a merge request to the INAV that introduces the SPI receivers, but I have not really checked that. So I think we can safely say, Mike's Adventures, that no, it's not there, unfortunately, at least not yet. Let me find the correct chat. Is there anything else? And now someone says about Golan. Okay, Olia is asking, where should we expect bidirectional D-Shot protocol support in the INAV? Something that Betaflight guys loves very much.
Oh, we should do another live stream on D-Shot specifically, I think.
Myth-busting
We
with
can
Pavel
spend
and Konstantin.
probably 1 hour talking about that.
Yeah, so the reaction of Konstantin and me should more or less give you the answer to that question.
Well, to be more clear, It's on the same list as H7.
So
Probably even
it's
lower.
somewhere there, but not really prioritized. Please, one more time to add something like a context to the problem. The bidirectional D-shot protocol allows the ESC to send the basic telemetry only with the RPM filter to the flight controller, so that the flight controller can update the RPM filter even faster. Not every, I don't know, 5 or 6 or maybe even 10 milliseconds, but the RPM filter can be updated after each update loop, which is happening at the rate of few kilohertz. However, in the INAV 2.6, the importance of the RPM filter was slightly lowered, and to be honest, it's right now not even advised to enable RPM filters because we have the better stuff. We have the Kalman, which is not really Kalman, but maybe... Okay, we will not talk about Kalman today as well, because that will be probably another hour of us talking.
Oh, Pavel, let me theorize a little bit here. What we can do with H7?
Okay, yes, please do.
Because of all the mighty CPU and more megahertz.
And you can have 2 cores.
Yes, we can do some really cool machine learning stuff. Our brain can predict stuff, but what if flight controller can predict stuff as well?
That would be pretty awesome.
Okay, so this might move H7 up the priority list.
I know that this year you were doing some pretty interesting experiments with some pretty fancy filters based on the... I don't even remember what it was based. Something about the Monte Carlo. I remember. Something about the Monte Carlo, and the result you showed us in the INAV Dev Talk channel was really like pretty impressive in terms of the prediction.
Results were awesome, but the CPU on our flight controllers was not nearly half time.
And please, from what you said back then, even the H7 single core is not powerful enough to do it.
Well, we have STMs with Cortex-A at 1.5 gigahertz running as a second core, I think. So that might be a possible way of doing something cool.
But not with F722, probably.
Oh, definitely not.
Okay, let me find the last question, if there is something interesting in the chat. Now it's time to scroll about... Ooh. Is there something super interesting? Rudder... Max is asking about the rudder control or bigger planes. One more time, I'm putting a lot of context today into our conversation. With the INAV 2.5, there was an addition of the rudder control for the navigation engine, but this is something that you basically have to enable manually, and you have to tune manually, because we never had enough of the point of the reference to tune the PID controller. Do you have anything to add to the topic, Konstantin? Why, for example, we are not using rudder control in INAV for the navigation?
Well, I wouldn't say we don't use it. We're just not using exclusively rudder. That might actually be doable. Like, keep the plane level and don't do banked turns.
Yes, keeping in mind that usually the rudder authority is pretty low on the airplanes, and it's like not really turning that fast as you might think it would.
Yeah, currently INAV, if the plane has a rudder, it will use it when flying in navigation modes.
But you have
to keep the nose level, basically. But you have to tweak it.
You have to tweak it, and you have to enable it. Okay, Konstantin, the hour right now is really over, so I think we should go back to our regular duties, because all of you, please do remember that we have lives, we have families, we have jobs, and the probably quite busy week about being a software developer for the different companies in Europe is finally over, and we have something like 2 days of not having to develop any software and while being paid for it. So thank you very much for being my guest today, and thank all the people who joined us for their two pretty technical dudes doing a talk about pretty technical stuff, and apparently they're at average 65% that were always interested in watching us talking about technical stuff. So I think that's a pretty good result. So thank you very much
That's a
for
pretty good result.
for visiting me over here. Maybe in a future, maybe I should do more interviews. Who knows? Thank you very much, and until the next one. Bye bye.
Bye. Thank you.